So before we can go much further, we really need to start adding view models. The reason is, for example, this drop down now. When we hover over, we have a change in animation, and when we go in here, we'll want to start making selections to do things. So I've done as much UI as I can before I feel we will need some kind of view models. So now's the perfect time to jump in and let's just get a handle of view models, MVVM, what the view is, what the view model is, what the model is. If we first take a look at the recommended Avalonia data binding, just like WPF, the view model gets passed into the view through the data context of the window itself. So when we refer to a binding inside of the XAML, for example here, binding, then it looks for button caption. It's going to start that search, as it mentions here, on the window itself, into the data context object, whatever that gets set to, which here is main window view model. So it will then look for button caption on the main window view model. So starting with the binding, that's where binding by default looks for a view model in a sense, and all that is an object. It can be any class at all, and it will search for properties that are public on there in order to find what it needs. The view model itself typically wants to be notifying the view when things change, and it does that through INotifyPropertyChanged. This is the typical way of doing things. And you can see here's an example using reactive UI, which I've never used, but it'll be similar to most MVVM platforms where all this base class is going to do is support ultimately firing an INotifyPropertyChanged on a property in order for the view to know that it's changed and refetch the data from the property. You can see we can do much more with binding paths. You can go into arrays, you can go into subproperties, you can set the mode one way or two way. So if the UI changes, the view has a text box, for example, and changes the text that's bound to a property on the view model, it can go backwards and set the property of the view model as well. There's string formats, and there's many other things. There's compile binding that we won't look at for now. There is binding to other controls. This is quite a cool one. So we can literally name another view element in the view. We can do a hashtag and the name of the other view item, and then get properties from that. This is specific to Avalonia as far as I know. That's a cool little feature that I've not seen anywhere else. And you can do the usual binding to ancestors, again with a cool kind of CSS selector to find the parent and get the tag of the parent. In WPF, this was a lot more laborious in terms of the syntax, so that's a cool one to see as well. But for now, skipping all of these things, we will just jump into view models, and I'll first show you how to do them manually, and then how I would recommend doing them. So I quickly added this fix that I forgot for the UI previewer to work. Interestingly, the main window always worked, but the main view failed to then work due to the SVG image issue. I've just added it to the desktop for now, and I think because my drop down here is set to use the desktop at the minute, then the main window view, then this main view is rendering as the desktop platform potentially. But either way, this works by just adding the fix to the desktop, so that's all I've done for now. So let's take a look at the main view, and we want to add some view models. So let's just start with a title, something nice and simple. So we're going to replace this title, Avalonia, and then loudness meter with some actual text inside of a view model instead of inside of the view. Now, the template already made a view model and a base, and it's using this reactive UI, which I'm not going to use, I can tell you for a start, because there's much easier ways of doing it than this seems a bit outdated and old school. And then there's a main view model. So I'm just going to delete all of this because we want to start from scratch, and you want to see how it's built up. When we do that, you can see now this fails to create a view model. And all this does is when the application starts, it detects if the application lifetime object, which is part of the Avalonia application, is a classic desktop style or a single view desktop style. And the reason for that is because it news up either a main window or a main view, depending on the type of application. And then once it's done that, it sets the data context to the same. This again will change to some kind of dependency injection, but for now, keeping it simple, the application starts, it figures out what type of application it is, and then it makes the starting window either the main window or the main view, and inside of that it sets the data context. So inside of this main view, the main one we currently have, this data context is set from here. So as I mentioned, a view model can just be a class. It doesn't need to be anything special. So let's just make a new class called main view model. And you can see there, it's just a class. There's nothing at all special about it. In here, it now builds. Let's just build the application and see if it works. And you can see here, we have a view locator, which, to be honest, I'm not sure where this is used. It's doing a data template of the application and then doing a view locator. Maybe this is something to do with the previewer finding that view model. So this is just currently checking if it's a view model base, which it won't be. So for now, I'm just going to return false and we'll come back to that. But I've got a feeling that is to do with the previewer maybe. So now that compiles, let's just run that. Now you can see it compiles and opens fine. So nothing's gone wrong. We can also breakpoint into here just out of curiosity to see this running. And when the application starts, you can see we are a classic desktop style application. And so for that, it sets the main window to a new window, which just instantiates this main view XAML. And it sets the data context of this main view, which if we go all the way inside of user control, content control, template control, then input, then interactive, then layoutable, then visual, then styled element. Finally, inside of styled element, which is just the class that all of these are inherited from, we should find data context. And you can see here it has a data context object. So buried deep within that, it pretty much shows you that every UI element inside of Avalonia has a data context. And as mentioned, anywhere inside of the XAML, we then use a binding. For example, on this label, if we were to get rid of this text now, and for the label instead, do content equals, open curlies, type binding, and now start typing something, you can see it's going to say data context equals main view model. So it already knows that. It's interpreted that from the code. And if we type something like, let's just do bold title, it's going to look now for bold title in the main view's data context object. And it's expecting something called bold title. So if we compile that now, it's going to fail to find that. It's not going to complain at this point because binding happens in real time. And it's actually failed silently in this case as well and not thrown an error, but you can see it's not bound to anything. But if we look at the application, we set the data context to main view model, and our main view model is a class. So it is going to be looking in here for a property called bold title. So if we just make a new property, public string, and call it bold title, and then do a getter, and return hello, we can put a breakpoint here, run the code, and you'll see that it should breakpoint here, and you can see it's breakpointed. And if we go all the way up the call stack, we can see the application started, it went to setup, it set the data context, it got notified of a property change, and that's simply because the view is appearing for the first time and it got forced into telling it that every property's changed. Goes through a whole load of things that we don't care about to ultimately come down to ask for our bold title. So if we just run that code, you can see now we already have hello bound to the title. So if we just change that to an easier syntax and change that to hello, you can see we've done nothing here except make a new class. There is no property change notification, there is no framework involved, there is nothing more than a simple class and a property. And this has worked because, number one, it set the data context here when the application started, and we could do this as simple as in here if we really wanted. We could just do data context equals new main view model. You could get rid of the data context here and run it, and this would still work. You can see we still have hello. So hopefully that's made quite clear that so far we're doing nothing special. We're just setting the data context to an object. And when you do that, inside of your view, you can now do content equals and then open curlies, binding, and then the path of anything that's on the view model that you set as the data context. So why do we need all the other stuff? Well, in order to update this, let's say we had a new constructor. And in here we did say a new task, and we were just lazy and did an await, I don't know, task.delay 2 seconds. And then after that, we set the bold title to new title. For that, we just have to do get and set the default value. And now we can attempt to set the value. If we run this code, we can also breakpoint here. So the application starts, says hello, do task.run rather, instead of just making the task. Try that again. I'll spin up, and 2 seconds later, hit the breakpoint, set the property, and you can see that this hasn't updated. So the purpose of MVVM, which is model view view model, is basically saying that you have a model, which is where this data would typically come from. It's where your actual data, nothing to do with the view specifically, comes from. So you have your model, then you have your view, which is clearly your main view, and then you have your view model, which is the thing that binds the model to the view in a specific way that makes the data presentable for the view. This should mean that we can just go ahead and set properties and have the view update automatically, because this is meant to represent the view. So the bold title is meant to represent whatever the view looks like. This is the text of that view. We shouldn't have to concern ourselves with constantly figuring out what the view is and updating the specific view. The view model should have no awareness of the view whatsoever. So how is the view model going to update the view? Well, the answer is it doesn't. The view listens for events on the view model of when to fetch data from the view model or set data to the view model. And it does that if we inherit from INotifyPropertyChanged interface. And we implement the interface. You can see now we have a new onPropertyChanged member. And as part of that, we have an event handler. So now if we do this, notifyPropertyChanged, when we set the data context to a view model, the engine in Avalonia, when it instantates a new view, will look if the data context is inheriting from INotifyPropertyChanged, and because we are, it will hook into this PropertyChanged event. So it's going to instantly hook into this, and whenever we call on PropertyChanged, we're going to then invoke any listener, which will be the view, and tally what property is changed by the name. So what we can do there then is to force the view to update now. We just do onPropertyChanged, and then we can do name of bold title and fire effectively this event. Now you can just replace that with the actual string, bold title. That's all we're doing, is passing in the actual string. But the problem with that is if we rename this property, this string goes out of sync. So I always do name of. If we run this now, we should find that we have a working MVVM binding. So the view pops up, says hello, and then 2 seconds later it's changed to new title. So you can see we've done nothing more than inherit from INotifyPropertyChanged, and then when we've changed the property, we actually tell the event to fire, which Avalonia has automatically hooked into. So that's all the view model platform that we use, whatever MVVM platform we use, whether it's the reactive UI, whether we make our own, or whether we use another one. Ultimately, all they're really doing is running this onPropertyChanged automatically for us whenever we change values. So a way around having to manually call onPropertyChanged everywhere you change the bold title would usually be to do this instead. So you'd have a getter, and now you'd have to return a value. You'd have to make a private backing field to store the same value. So you'd have bold title. You can now return. In fact, if we do the syntax a little bit easier, you can now return bold title and then set. We can now do bold title equals the value. And then you can do on property changed, name of bold title. And then this will automatically fire the on property changed every time we change the value. We'd normally also add if bold title is equal to the value, then return, so you don't fire whenever it changes to the same value. We can get rid of the property changed here, and this will work the same. So if we do new title 2 and run this, you'll see that we've achieved the same thing just in a different way. And you can see there now we forgot to set the default value on here to say hello. And then this will default to hello and then change back to the new title. So what's the problem with this? Well, the problem we have now is we have a private backing field where we set the default value. Then we have a public property that we have to define with the same name, just without the lowercase m for my members. Then we have to implement a getter that returns that. We have to implement a setter that does this check every time. We have to set the backing field. Then we have to call on property changed. You have to do this for every single property in your entire class. So this becomes a lot of boilerplate code that you don't want to have to see in every single instance of every property on every view model. You want to automate this as much as possible. To make things more complicated, you don't only just have INotifyPropertyChanged, you also have INotifyCollectionChanged, which is for arrays and lists and things like that. You then also have commands, which are effectively methods and functions that fire when you typically click buttons or you want some action to be performed. So you can think of that like, instead of a property, it is a method that does something. So a command is like a method. But the same thing will apply if we do this all manually. We have to do all this boilerplate code. So you can see that it's easy to implement the view model, and hopefully you realize there's nothing special going on here. But we want to automate that. So what I'm going to use is the same thing that .NET uses for Blazor and their latest code. And it's just an MVVM tool that will automatically add this boilerplate code in real time for us. Whereas the Avalonia recommended tool, the Reactive UI, still requires you to do most of this manual code. It's not really of much use. So I'm going to get rid of all this code here, because this is what's going to be auto-generated. And then I'm going to remove the INotifyPropertyChanged for the moment. Remove all of this code, because that's not needed anymore. All this is going to be done for us. And then in this loudness meter project, I'm just going to right-click, manage NuGet properties, manage NuGet packages. I'm going to type community toolkit, and we want this community toolkit.mvvm. We install this into this project, not into the whole solution. And what this will do now is allow us to have all of those features automatically done for us. And all we have to do to gain that is, for the view model class we want it to work with, change it to an observable object. And that's part of the community toolkit MVVM component model namespace. Once we've done that, this will inherit from, if we look inside, INotifyPropertyChanged for us. And then all we need to do to auto-generate the actual property is to add an attribute to this private property and call it observable property. And this is real time. This will generate the code in real time for us. You can see instantly it's complaining now that the class isn't partial because the community toolkit is trying to generate more features in this class for us. So add partial here. This allows for two code files to have the same name and be part of the same class. So now it will have already done this instantly as we typed. It will have compiled the code. And if we look in the class, you'll find we type bold title. We have one here, and we also have one here with a capital M. And this is the auto-generated property that the community framework has done for us. So because I typically use a lowercase m before the names, and the way the community toolkit works is it simply wants to uppercase the first letter. Let's just change that from bold title to just bold title. And now it discovers bold title because the toolkit has made that property for us, and it's going to automatically implement the notify property changed. So the code now is as simple as making the view model inherit from observable object, and anywhere we want a property to be responding in the view, i.e. whenever we change its value, it responds in the view, we just add an observable property. Let's just check this works still. Press F5 and make sure everything is actually functioning. We've got hello, and then 2 seconds later, new title too. Now, one thing you might accidentally slip up on, as expected, is you'll just type bold title, for example, and you'll do that, and it will work and run. But what do you think is going to happen here? The code runs, says hello, 2 seconds later, nothing happens. And that's because we've accidentally used the exact property, the private property. So this code is doing nothing special here. This is just a string. The difference is we put the capital B, and it's not the string, it's the property that got generated that has all that code in there, like the property we wrote manually. So just make sure when you're setting the value to make it the uppercase version of your actual property. So with that, we already have now a view model that we can start doing things with. So let's just make it actually useful. And we want the bold title to be Avalonia. And then we just copy and paste that. We can make another one, and we'll call it regular title. And this will be loudness meter. Then if we go back into here, we bind the content of the other label instead of actually saying loudness meter. And we'll change this to regular title. We should just be able to build and see this update in the developer. And you can see even the code to update the title runs in this preview. So for now, we've seen how we can change them. We don't need to do that there. So our view model is as simple as this so far. Just 2 properties with observable property tagged to them, and then the view model bound to the uppercase versions of those properties. And now it looks the same, but we actually have a view model. So that's an introduction into view models, and hopefully it's demystified what some people think is a complicated task or something with hidden magic, and you've seen how basic it really is. And ultimately all we're doing is changing values on a class that automatically fire events to tell the view to now fetch those new values. That's ultimately the key of MVVM, as well as separating the view model from the distinctive view and separating the data from view-specific constructions of that data. So, for example, titles in the views might not have any relevance anywhere else except in a specific view. But we'll get much more into that as we go. The main benefit now is we have view models, so we can start doing things like the bottom buttons and having these buttons have arrows that change based on properties in the view that are linked to the view model. So that's it for this one, guys, and I'll catch you in the next.